So guys, in today's video we are going to deal with the two important nucleophilic addition reaction. That is, first one is the addition of alcohol and the second one is the addition of grignard reagents. Addition of grignard reagents. Of course, this part, that is the second part, is once again repeating because in the chapter of alcohols, phenols and ether, we have studied these reactions under the concept of preparation of alcohols from grignard reagents. So when I am coming to this topic, it is better that you first only get to know what are the things we have learned earlier, try to recollect the things so that it would be easy when I am explaining it under the concept of nucleophilic addition reactions. So coming to the first point, let me start my video with addition of alcohols. So remember guys, whenever we are talking about the addition of an alcohol with a grignard reagents, you're mainly going to get two types of a product. I repeat, you're mainly going to get two types of the product, and both the types of the product depend upon what is the ratio of alcohol you have taken for the reaction with aldehydes or ketones. Are you getting my point? If not, you will come to know when I am going with my reactions. So before that one, let me write my topic, that is addition of alcohol to carbonyl compounds. Yes. So first of all, let me give you a brief knowledge of what type of a product we are going to get, because I have mentioned in my earlier videos, in all these nucleophilic addition reactions, you have to remember the name of the products. As when you are treating with a HCN, we have got cyanohydrin. When you are treated with a sodium bisulfate, of course, we have got a product which is also called as a sodium bisulfite white crystals. Yes. And now when we are dealing with the alcohol, do remember, when aldehyde is treated with alcohol, so we are going to get first important product name is called as a hemiacetal. It is called as what? Hemiacetal. Treating this alcohol, the hemiacetal, with once again with the alcohol, so you will be getting acetal. You will be getting acetal. So these are the two important products we are going to get when you are treating aldehyde with alcohol. Similarly, when you treat ketones with alcohol, first you are going to get as a hemiketal. Hemiketal. Once again treating hemiketal with the alcohol, you will be getting the final product which is called as a ketal. Now let me say you what I have said earlier. What did I say? So whenever your carbonyl compounds are treated with the alcohol, you're going to get two important types of the product. So you could just see that. One is a hemi, another is a complete product. Aldehyde tagondaga hemiacetal, the final product is an acetal. Ketones tagondaga hemiketal, final product will be ketal. And I also mentioned that whatever the product you're going to get, it depends upon what? The ratio of alcohols. Why did I say it? Because remember, whenever aldehydes are treated with just 1 mole of alcohol, you're going to get what? Hemiacetal. But if the aldehydes are treated with 2 moles of alcohol, I repeat, when aldehydes are treated with 2 moles of alcohol, you're going to get what? Acetal. So generally, if I want to say them in ratio, what I can say, if aldehyde is to alcohol, if aldehyde is to alcohol is in the ratio of 1:1. 1 mole aldehyde tagondidira, 1 mole alcohol tagondidira. So aವಾಗ ನಿಮಗೆ ಏನು ಬರುತ್ತೆ product to hemiacetal. You're going to get as what? Hemiacetal. If the same thing if I take in 1:2 ratio, that is if aldehyde is 1 mole, alcohol is 2 mole, then the final product directly it will be giving you what? Acetal. So that is the reason I have said you, whenever you're treating your carbonyl compounds with alcohols, you're going to get two important types of the product, and those product depends upon the ratio of the alcohol you have taken. Similarly, when you take for ketone plus alcohol, if in the ratio is 1:1, that is 1 mole of ketone, 1 mole of alcohol, what you're going to get? Hemiketal. Hemiketal. Similarly, if it is 1:2 ratio, so you'll be getting as what? Ketal. So ultimately our final product depends upon what is the ratio of alcohol you are choosing, because in both the cases it may be a carbonic compound, that is aldehydes and ketones. We have just opted to choose just 1 moles. ಅಲ್ವಾ, ಅಥವಾ 1:1 ರೇಷಿಯೋದಲ್ಲಿ ತಗೊಂಡಿದ್ದೀವಿ. ಚೇಂಜ್ ಮಾಡ್ತಾ ಇರೋದು ಯಾವ್ದು ನಾವು ಆಲ್ಕೋಹಾಲ್ನ ಮಾತ್ರ. ಆಲ್ಕೋಹಾಲ್ನ 1 ರೇಷಿಯೋದಲ್ಲಿ ಇಟ್ಟಾಗ ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ, ಹೆಮಿ ಪಾರ್ಟ್ ಸಿಗ್ತಾ ಉಂಟು ರೆಸ್ಪೆಕ್ಟಿವ್ ಆಗಿ. ಅದನ್ನ ನೀವು 2 ಮಾಡಿದಾಗ ಆಲ್ಡಿಹೈಡ್ ತಗೊಂಡ್ರೆ ಅಸಿಟಾಲ್ ಬರುತ್ತೆ, ಕೀಟೋನ್ ತಗೊಂಡ್ರೆ ಕೀಟಾಲ್ ಬರುತ್ತೆ. ಇಸ್ ದ್ಯಾಟ್ ಕ್ಲಿಯರ್? ಅಂಡ್ ಒನ್ ಮೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್, ರಿಮೆಂಬರ್, these reactions are being carried out in the presence of dry HCl gas. Whenever we are treating aldehydes with the alcohols, whatever the hemiacetal or acetal you are going to get, in both the cases we are using dry HCl gas, which I am going to explain soon after we have seen the reactions. But before that one, you have to have the knowledge that whenever the carbonyl compounds are treated with the alcohols, first you are going to get hemiacetal. Treating that hemiacetal with 1 more mole of your alcohol, we are going to get acetal. Similarly, in the case of the ketones, first you are going to get a hemiketal and finally ketal. Is that clear? Let us go with the reaction, general reactions. So basically, if I write for aldehydes, the general representation is R, C, double bond O and H. Yes. So treating this aldehyde with the alcohol, let me write my alcohol in this way: O, H, R. Yes. Of course, what do I know? This is going to take, oxygen is going to take its pi electrons. Soon after, what happens? Carbon will be having a positive charge on it. So ನಮ್ಗೆ ಏನ್ ಗೊತ್ತು, H plus ಹೊರಗೆ ಹೋಗ್ತಾ ಉಂಟು. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇದೀಗ O minus ಆಗಿರುತ್ತೆ. ಹೌದು ಅಲ್ವಾ? So now this, utilizing now whatever the lone pair of electrons which is present on the oxygen, so that is coming to attack your carbon, whereas this hydrogen has been gone over here. So ಯಾವ ತರ ಬರುತ್ತೆ ಪ್ರಾಡಕ್ಟ್ ನೋಡೋಣವೇ? ಸೊ R, C, O, H, because this O minus is attracting your H, and see the bonding is from O to R, not from RO. It is OR. So just write over here as O, R, and whatever is remaining as a H. So this is called as what? Hemiacetal. Now you have to pay attention when I am writing for acetal. Hemiacetal ಇಂದ ಈಗ acetal ಗೆ ಹೋಗಬೇಕು. So again ಮಾಡ್ತೀನಿ ನಾನು, once again I would be taking now 1 more mole of the same alcohol, so ROH. Yes. So now you just see what happens. You'll be getting as an RC, illu kuda OR, illu kuda OR, and here you will be having as a H. So this is called as what? Acetal. Getting my point? Hemi andre ಅರ್ಧ. ಏನಾಗಿದೆ ಇಲ್ಲಿ? R ಇಲ್ಲಿ ಏನಾಗಿತ್ತು? OH ಇತ್ತು. ಅಸಿಟಾಲ್ ಅಲ್ಲಿ ಏನಾಯ್ತು? ಎರಡು ನಮಗೆ R ಬಂತು. So this is the way your reaction is getting progressed. So whenever the aldehydes are treated with an alcohol, just with 1 mole of alcohol, first you are going to get an hemiacetal by the nucleophilic addition reaction. Treating once again with it alcohol, you will be getting as a complete acetal. Is that clear? I hope no doubt. Can we go with one important reaction? Let us take one group. Let me take CH3, C, double bond O and a H. Now treating this one with ethanol, C2H5OH. So see, the reaction is in equilibrium, very much important. You have to note all these things. So first time barutte nimage CH3, C, illen barutte OH. This H has come over here. Carbon ಮೇಲೆ again attack ಆಗುತ್ತೆ, ethoxy group attack ಆಗುತ್ತೆ. That is from O, C2H5 and you are having your H. Once again, now it is in equilibrium, treating it with the same alcohol, C2H5OH. So what are you going to get? CH3, C, OC2H5. Here also OC2H5 and here is your H. So what I can name this compound? 1,1 diethoxyethane. 1,1 diethoxyethane. Yes or no? So what you have got? From a hemiacetal, you have got a acetal. Acetal in ಹೆಸರು ಏನು ಬರುತ್ತೆ? 1,1 diethoxyethane. ಅದೇ hemiacetal ಗೆ ಏನು ಬರುತ್ತೆ ಇಲ್ಲಿ? 1 ethoxy ethanol. 1 ethoxy ethanol. You getting the difference? So this is the way of representation whenever you are writing for aldehydes treating with your alcohols. But do remember, first this part ಏನೇ ಬರ್ದಿದ್ದೀನಲ್ಲ 1 ethoxy ethanol, it is generally called as what? Hemiacetal. Whatever I have written as 1,1 diethoxyethane, whatever it may be. But whenever an aldehyde is written with a 1 mole of alcohol, first you should get a hemiacetal. This is a general representation of hemiacetal. Treating the hemiacetal with the same alcohol with a 1 more mole, you will be getting a acetal. So this is a general representation of acetal. Is that clear? I hope there is no doubt in it. Similarly, let us go with now my ketone. Okay, I will be taking directly a reaction. For example, R, C, double bond O and a R. Why I am writing this, you'll come to know. So whenever a ketone is treated with ethylene glycol, let me take it as an ethylene glycol, CH2OH, CH2OH. Yes, what is the IUPAC name? Ethane 1,2 diol. But generally we call it as what? Ethylene glycol. One of the most used name. Instead of saying as a ethane 1,2 diol, in most of the cases we used it as a name, as a common name, ethylene glycol. So IUPAC name, if you remember, it's well and good. Ethane 1,2 diol. Yes, see, D is there. I have not eliminated E. E should be present. Ethane 1,2 diol. So now here what happens? You are going to get a cyclic product. Okay, remember, in the presence of dry HCl, I have to mention in all the cases. In the presence of dry HCl gas only, the reaction is being carried out. So now first what happens? Of course, here also the same phenomenon. First you should get what? Here directly you will be getting a ketal product. Let me write first directly the ketal. So R, C, R. Yes. So we'll be getting as a OCH2. Here also we'll be getting as a CH2OCH2. So this is directly you're getting as what? Ketal. Now direct ag bardidhi first. Problem enilla. First ig naan step by step baritidini andaga, let me write you a general reaction so that there will be no confusion. So this is my ketone. So first enagutte, let me take my alcohol ROH. So idige illi elkonutta. So aವಾಗ ಏನಾಗುತ್ತೆ? So this is also in equilibrium. ಇದೇನಾಗುತ್ತೆ ಬಂದು ಇಲ್ಲಿಗೆ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ. So RCOH ROR. ಏನು ಡಿಫರೆನ್ಸ್? ಆಲ್ಡಿಹೈಡ್ ನ ತಗೊಂಡಾಗ ಈ ಪ್ಲೇಸ್ ಅಲ್ಲಿ H ಇತ್ತು ಅಲ್ವಾ? ಅದೇ ನೀವೇನಾಗುತ್ತೆ ಕೀಟೋನ್ ತಗೊಂಡಾಗ ಆ H ಪ್ಲೇಸ್ ಅಲ್ಲಿ ನಿಮಗೆ ಒಂದು ಆಲ್ಕಿಲ್ ಗ್ರೂಪೇ ಇರುತ್ತೆ. Since once again you treat this one with the same alcohol ROH, what you will be getting? RCOR ROR. So this is the way of representation of your ketal alva. ನೋಡಿ ನೀವು ಕೂಡ RC, ಇದು ನಾವು ಸೈಕ್ಲಿಕ್ ಪ್ರಾಡಕ್ಟ್ ಬಂದಿದೆ. ಸೊ ನಿಮ್ಗೆ ಇಲ್ಲಿ ಕನ್ಫ್ಯೂಷನ್ ಆಗುತ್ತೆ ಅಂತಾನೆ ನಾನು ಈ ತರ ಬರ್ದಿರೋದು, ಬಿಡಿ ಬಿಡಿಯಾಗಿ ಬರ್ದಿದ್ದೀನಿ. ಇದ್ಯಾಕೆ ನಮ್ಗೆ ಈ ತರ ಬಂತು? ಬಿಕಾಸ್ ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ 1,2 ಡೈಆಲ್ ಒಂದೇ ಸರಿ ತಗೊಂಡಾಗ ನಂಗೆ ಏನಾಯ್ತು, 2 OH ಗ್ರೂಪ್ಸ್ ಒಂದು ಒಂದ್ಸರಿ ನಂಗೆ ಕೀಟಾಲ್ ಬರೋ ಚಾನ್ಸಸ್ ಸಿಕ್ತು. ಆದ್ರೆ ನಾನು ಎಲ್ಲರೂ ಬರೀ ಒಂದೇ ಮೂಲ ತಗೊಂಡಾಗ ಏನಾಗೋದು, ಬರೀ ಒಂದೇ OH ಫಸ್ಟ್ ಅದು ಹೆಮಿ ಕೀಟಾಲ ಕನ್ವರ್ಟ್ ಆಗಿ ಆಮೇಲೆ ಅದೇನಾಗಬೇಕು, ಕೀಟಾಲ ಕನ್ವರ್ಟ್ ಆಗಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ ದ ಜನರಲ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ಸ್ ಆಫ್ ಯುವರ್ ಹೆಮಿ ಕೀಟಾಲ್ ಅಂಡ್ ಕೀಟಾಲ್. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? So if I take one example for this one, idukkondu example tagonanve. If I take CH3, C double bond O and CH3, and you treat this one with OH, single bond CH2, single bond CH2, OH. Yes. So ಏನು ಬರುತ್ತೆ ಈಗ? CH3, CH3, OCH2, CH2 and a O. Yes or no? So what we can call this? 2,2 dimethyl 1,3 dioxolane. Of course, it's a new name for you. No need to confuse. I don't want to confuse you. But you just remember how to write the products. That is very much important. Okay, plus H2O, it will be gone. Is that clear? I hope there is no doubt. Just you remember how to write a general way of representation. Ethylene glycol na consider ಮಾಡಿದಾಗ ನಿಮಗೆ cyclic ketones ಬರ್ತಾ ಉಂಟು. ಅದೇ ನೀವು ನಾರ್ಮಲ್ ಆಗಿ ತಗೊಳ್ಳಿ, ನಾವು ಯಾವ ತರ ಆಲ್ಡಿಹೈಡ್ಸ್ ಬಂದಿದ್ವಿ ಅದೇ ರೀತಿ ನೀವು ಹೆಮಿಕ್ ಕೀಟಾಲ್ ಮತ್ತೆ ಕೀಟಾಲ್ ಬರುತ್ತೆ. ಆದ್ರೆ ಆಲ್ಕಿಲ್ ಗ್ರೂಪ್ಸ್ ಮಾತ್ರ ಒಂದ್ ಸ್ವಲ್ಪ ನೀವು ಗಮನ ಕೊಡಬೇಕು. ಇಲ್ಲಿ ಏನಾಗಿತ್ತು, H ಬಂದಿದೆ ಹೆಮಿ ಅಸಿಟಾಲ್ ಮತ್ತೆ ಅಸಿಟಾಲ್ ಅಲ್ಲಿ. ಹೆಮಿ ಕೀಟಾಲ್ ನ H ಜಾಗದಲ್ಲಿ ಒಂದು R ಗ್ರೂಪ್ ಉಂಟು. That's the difference. Is that clear? I hope there is no doubt. As I have mentioned, why I am using my dry HCl gas? In order to increase the rate of my nucleophilic addition reaction. How is that possible? Of course, what happens whenever I am using an aldehyde and treating it with some proton, what it will do? Of course, by utilizing the lone pair of electrons, this H plus is going to attack. So directly what will be happening? RC double bond O OH plus alva. ಇದೇನಾಗ್ತಿತ್ತು, ಈಗ ಆಕ್ಸಿಜನ್ ಮೇಲೆ ಪ್ಲಸ್ ಬಂದೇ ಬಂತು. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಬೇಗನೆ ನಿಮ್ಮ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ತನ್ನ ಕಡೆ ಎಳ್ಕೊಂಡು ಕಾರ್ಬನ್ ಮೇಲೆ ಅತಿ ಬೇಗವಾಗಿ ನಮಗೆ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಬಂದ್ಬಿಡುತ್ತೆ. ಅವಾಗ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಈಸಿಯಾಗಿ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ. ಸಿನ್ಸ್ ಇನ್ ಆರ್ಡರ್ ಟು ಇನ್ಕ್ರೀಸ್ ದಿ ರೇಟ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ವಾಟ್, ಡ್ರೈ HCl ಗ್ಯಾಸ್. ಆ ಡ್ರೈ HCl ನ ಪ್ರೋಟಾನ್ ಫಸ್ಟ್ ಆಕ್ಸಿಜನ್ ಅಟ್ಯಾಕ್ ಮಾಡಿ ಆಕ್ಸಿಜನ್ ಮೇಲೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರಂಗ್ ಮಾಡ್ಕೊಳುತ್ತೆ. ಒಂದ್ಸರಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬಂದ್ಮೇಲೆ ಏನಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿಯಿಂದ ಹೋಗ್ತಾ ಇತ್ತು ಫಸ್ಟ್. ಈಗೇನ್ ಮಾಡ್ತಾವೆ, ಅದಕ್ಕೆ ಅನಿವಾರ್ಯ ಈ ಪ್ಲಸ್ ನ ಅದು ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಲೇಬೇಕು. ಸೊ ಅದು ಏನ್ ಮಾಡುತ್ತೆ, ಈ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ತಗೊಂಡ್ಲೇಬೇಕು, ಬೇಗನೆ ತಗೋಬಿಡುತ್ತೆ, ಕಾರ್ಬನ್ ಮೇಲೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬೇಗನೆ ಬಂದ್ಬಿಡುತ್ತೆ. ಸೊ ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್ ಕೂಡ ಬೇಗ ಆಗ್ಬಿಡುತ್ತೆ. ದಿಸ್ ಇಸ್ ದಿ ಫಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕೇಸ್. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಅಂಡ್ ದಿ ಸೆಕೆಂಡ್ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್, ರಿಮೆಂಬರ್ I said you to remember that in all the cases we are getting what, equilibrium arrow. That means what, forward direction ಎಷ್ಟು ಉಂಟು ರಿಯಾಕ್ಷನ್, ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಅಷ್ಟೇ ಉಂಟು. ಯಾಕೆ ಹೇಳ್ತಿದ್ದೀನಿ ಅಂದ್ರೆ, ಒನ್ಸ್ ನಮಗೆ ಅಸಿಟಾಲ್ ಬಂದ್ಮೇಲೆ, ಅಸಿಟಾಲ್ ಅಥವಾ ಕೀಟ ಯಾವುದೇ ಆಗಿರ್ಲಿ, ಇದನ್ನ ನೀವು ಒನ್ಸ್ ಅಗೇನ್ ಒಂದು ಮಿನರಲ್ ಆಸಿಡ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಟ್ ಕುಡ್ ಬಿ ಯೋರ್ ಎಕ್ವೆಸ್ ಮಿನರಲ್ ಆಸಿಡ್, H2SO4 HCl ವಾಟರ್ ಡಿಸಾಲ್ವ್ ಮಾಡ್ಕೊಂಡು ಆಡ್ ಮಾಡ್ತಿದ್ದೀರಾ ಅಂದಾಗ, ಆ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಆರೋ ಸೇಮ್ ಇರೋ ಕಾರಣದಿಂದ ಏನಾಗುತ್ತೆ, ಬ್ಯಾಕ್ ಶಿಫ್ಟ್ ಆಗಿ ಒನ್ಸ್ ಅಗೇನ್ ಯು ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ಯುವರ್ ರೆಸ್ಪೆಕ್ಟಿವ್ aldehydes or ketones. Getting my point? Whatever the acetal or ketal you have obtained, once again if you treat that one with aqueous, mark my words, aqueous H2SO4 or HCl, the reaction once again goes back and it will be giving you what, corresponding aldehydes and ketones. Is that clear? So till now what we have come to know, so whenever you are treating your carbonyl groups with alcohols, you are going to get a nucleophilic addition product. In case of aldehydes, you are going to get an hemiacetal and an acetal, depending upon what is the ratio of alcohol you have chosen. Similarly, in case of the ketones, you will be getting hemiketal and a ketal. Is that clear? So when you are getting a hemiacetal or a hemi products, when you are getting, whenever you are using 1:1 ratio, that is 1 ratio, 1 mole of your aldehydes or ketones and 1 mole of your alcohols. If you want to get acetal and a ketal, you have to use 2 moles. What do you have to use? 2 moles of your aldehydes, or 2 moles of your alcohols. Similarly, in ketals, it was something a different task because we have used what? Ethylene glycol, where itself you are having a 2 hydroxy group, so directly it will be giving you what? Ketal products. Is that clear? And but also you just remember, if you want to write, ಈಗ ಎಲ್ಲರೂ ಒಂದೇ ಹೈಡ್ರಾಕ್ಸಿ ಗ್ರೂಪ್ ಕೊಟ್ರಪ್ಪ, ಅವಾಗ ಹಿಂಗ್ ಬರಿಬೇಕು, ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಯಾವ ತರ ಆಲ್ಡಿಹೈಡ್ ಬರ್ತಿರ್ತೀವಿ, ಆ ಹೆಚ್ ಬದಲು ನೀವೇನ್ ರಿಪ್ಲೇಸ್ ಮಾಡಬೇಕು, ಆರ್ ನ ರಿಪ್ಲೇಸ್ ಮಾಡಬೇಕು. ಸೊ ಫಸ್ಟ್ ನೋಡಿ, ಹೆಮಿಯಸಿಟಾಲ್ ಹೆಮಿಕೀಟಾಲ್ ಅಲ್ಲಿ ಏನು ವ್ಯತ್ಯಾಸ ಅಂದ್ರೆ, ಒಂದು OH ಗ್ರೂಪ್ ಇರುತ್ತೆ ಹೆಮಿಯಲ್ಲಿ, ಅದೇ ಕೀಟಾಲ್ ಅಥವಾ ಅಸಿಟಾಲ್ ಅಲ್ಲಿ ಆ OH ಬದಲು ಏನಾಗಿರುತ್ತೆ, ಆರ್ ಬಂದು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಗಿದೆ. 2 ಕೇಸಲ್ಲಿ ನೀವು ನೋಡಬಹುದು ಅಲ್ವಾ. ಇಲ್ಲೂ OH ಇತ್ತು, ಇದು ನಾವೇನಂದ್ವಿ, ಹೆಮಿ ಅಂದ್ವಿ. ಇಲ್ಲೇನಿತ್ತು, ಕೀಟಾಲ್ ಅಲ್ಲಿ ಕೂಡ ಒಂದು OH ಇತ್ತು, ಇದನ್ನ ಹೆಮಿ ಅಂದ್ವಿ. ನಿಮ್ಗೆ ರಿಯಾಕ್ಷನ್ ಪ್ರೋಗ್ರೆಸ್ ಗೊತ್ತಾಗ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಇದನ್ನೆಲ್ಲ ಬೈ ಹಾರ್ಟ್ ಮಾಡೋದೇ ನೆಸೆಸಿಟಿ ಇಲ್ಲ. ಯು ಕ್ಯಾನ್ ಓನ್ಲಿ ಈಸಿಲಿ ರೈಟ್ ಇಟ್. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಸೊ ನೋ ಡೌಟ್, ಐ ಹೋಪ್. ಸೊ ದ ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾರ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡೀಲ್, ದಟ್ ಈಸ್ addition of grignard reagents. So guys, now let us deal with another important part, that is addition of grignard reagents. Of course, we have dealt with it when we were dealing with the preparation of alcohols from the carbonyl compounds. But actually there we have not noticed that how does the reaction is proceeding. Just we have given a basic knowledge. Yes, what will we say over there? Whenever your carbonyl compounds, that is your aldehydes, is treated with that of your grignard reagents, followed by acid hydrolysis, you will be getting a primary and a secondary alcohols. And similarly, when you treat ketones with your grignard reagents, followed by acid hydrolysis, you will be getting a tertiary alcohol. And I have mentioned you very much important points. What is that? Whenever we are using a formaldehyde, and treating that one with a grignard reagent, RMgX, followed by your acid hydrolysis. So what you're going to get over here is the primary alcohol. Very much important. Once again, I am mentioning it. Yes, the same reactions we are going to study. Then any other aldehydes other than your formaldehyde, any other aldehydes other than that of your formaldehydes treated with that of your RMgX, grignard reagent, followed by acid hydrolysis. This is very much important. Gives you what? Secondary alcohol. Similarly, if you choose ketones and treating that one with your grignard reagent followed by acid hydrolysis, you would be getting tertiary alcohol. Yeah, very much important, both in the point of your pure board exam and also in the point of your competitive exam. ನೋಡಬೇಕು ಯಾವ ತರದ ಆಲ್ಡಿಹೈಡ್ ನ ಯೂಸ್ ಮಾಡಿದ್ದಾರೆ. ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಬರೋದು ನಮಗೆ ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್. ಬರೀ ನಮಗೆ ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಇಂದ ಮಾತ್ರ ಗ್ರಿಗ್ನಾರ್ಡ್ ರಿಯೇಜೆಂಟ್ ಹಾಕಿದಾಗ ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್ ಬರುತ್ತೆ. ಇನ್ನು ಯಾವೇ ಆಲ್ಡಿಹೈಡ್ ಹಾಕಿದ್ರು ನಮಗೆ ಬರೋದು ಸೆಕೆಂಡರಿ ಆಲ್ಕೋಹಾಲ್. ಅದೇ ರೀತಿ ಕೀಟೋನ್ಸ್ ನೀವು ಟ್ರೀಟ್ ಮಾಡಿದ್ರೆ ಗ್ರಿಗ್ನಾರ್ಡ್ ರಿಯೇಜೆಂಟ್ ನ ಫಾಲೋಡ್ ಬೈ ಆಸಿಡ್ ಹೈಡ್ರಾಲಿಸಿಸ್, ಯು ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ವಾಟ್? ಟರ್ಷರಿ ಆಲ್ಕೋಹಾಲ್. Of course, we have read through it. But now when the question is coming with respect to the nucleophilic addition reaction, we have to think a bit. What is that? Why it is coming under nucleophilic addition reaction? Which is the nucleophile over here? In order to understand that, let us go now with one by one reactions once again. That is, if I am going to write my formaldehyde, HC double bond OH. So when I write my Grignard reagent, how I am going to write? R MgX. Of course, I have said you, whenever we are writing a Grignard reagent, RMgX, we have dealt with it. Your R group will be having what charge? Yes, delta minus. Magnesium is a metal, it will be having a delta plus. So of course, here only you are getting the knowledge that which is your nucleophile. Yes, it is the alkyl group. So now what happens? As usual, the pi electrons will be taken by your O. Yes or no? So once it has been gone over there, so what you will be going to get? HC, remember ಈಗ O minus ಉಂಟು, ಇಲ್ಲಿ MgX ಈಗ ಪ್ಲಸ್, ಇಷ್ಟು ಈಗ ಏನಾಗಿರುತ್ತೆ ಪ್ಲಸ್ ಆಗಿರುತ್ತೆ. So HC O MgX, since this is R is negative, our carbon is positive, R ಇಲ್ಲಿ ಕಮ್ಮಿ ಇರುತ್ತೆ, here will be getting as a H. Since a nucleophile is attacking the carbonyl group, I repeat, since a nucleophile is attacking the carbonyl group, so it is falling under the category of nucleophilic addition reaction. So whenever, you should just remember now, when you are going with respect to that of your exams, yeah, both in competitive as well as in the PU board exam, you should come to know what is the part. Whenever we are reading for alcohols, in the preparation of alcohols, you should come to know, okay, this is the concept which will also come under the nucleophilic addition reactions of carbonyl compounds, because there is a nucleophilic attack on the carbonyl compounds in these reactions. So of course, now what is this? This is an adduct. This is an adduct. Now following this one with an acid hydrolysis, H3O plus, yes. So what you are going to get? HC. So OMgX ಭಾಗದಲ್ಲಿಗ OH ಬರುತ್ತೆ, R and a H. So what are you going to get? RCH2OH. If I am going to write, ಹೆಂಗ್ ಬರೀಬಹುದು ಇದನ್ನ equivalently, if I am writing RCH2OH, where our hydroxy group is attacked to the primary carbon atom. ಅಲ್ವಾ? Primary carbon atom ಅಂದ್ರೆ ಅರ್ಥ ಏನು? The carbon which is bonded to another single carbon atom. So this is giving you what? Primary alcohol. And when we got this, whenever we are using an aldehyde as a methanol, methanol is the IUPAC name, or common name hodre formaldehyde, formaldehyde. Are you getting my point? Similarly, if I am going to choose my any other aldehydes, for example, R, C, double bond O and a H, treating that one with RMgX, that is your Grignard reagent. So what is the type you are going to get? The same way you have to write. There's nothing more difference. So first RC, so ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ OMgX. Yes, since your R minus, C is having a positive, so here comes R, here comes H, followed by acid hydrolysis. Once again I am repeating, first to adduct ಬರುತ್ತೆ, ಆಮೇಲೆ ಅದನ್ನ acid hydrolysis ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಬರೋದೇ final product as an respective alcohols. In this case, a secondary alcohol. So RCOH, H and a R. So why it is called a secondary alcohol? Because the hydroxy group is attached to the secondary carbon atom. ಏನು secondary carbon atom? The carbon atom which is bonded to two other carbon atoms. ಅಲ್ವಾ? This is R ಅಂದ್ರೆ it can be any alkyl group. For example, CH ತಗೊಂಡೆ, ಇದು ಒಂದು C, ಇಲ್ಲಿ ಒಂದು C. So this carbon is attached to two other carbon atoms. ಅಲ್ವಾ? So it is a secondary carbon. ಆ secondary carbon ಗೆ ನಮ್ಮ hydroxy group attach ಆಗಿದ್ರೆ, that is called as what? Secondary alcohol. So when did you get this? When you are using aldehydes other than or except ಮೆಥೆನಾಲ್ ಅಂಡ್ ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್. ಈ ಮೆಥೆನಾಲ್ ಮತ್ತೆ ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಅದನ್ನ ಹೊರತುಪಡಿಸಿ ಯಾವುದೇ ಬೇರೆ ಆಲ್ಡಿಹೈಡ್ಸ್ ತಗೊಂಡ್ರು ನಿಮಗೆ ಬರೋದು ಯಾವುದು? ಸೆಕೆಂಡರಿ ಆಲ್ಕೋಹಾಲ್. Go with the ketones. Yeah, come along with me. You also do it. RC double bond OR plus RMGX. So here what you're going to get? RCOMGX and a R plus here one R. So treating this one with the acid hydrolysis. So you'll be getting as RCOH R and a R. So what it is? A tertiary alcohol. Why? Because a hydroxy group is attached to the tertiary carbon atom. ಏನು tertiary carbon atom ಅಂದ್ರೆ? The carbon atom which is bonded to 3 other carbon atoms. ಅಲ್ವಾ? ಈ single carbon atom ನೋಡಿ ಇನ್ನು 3 carbon atom ಗೆ join ಆಗಿದೆ. So this is called as what? Tertiary alcohol. And when you are getting this, when you are treating ketones with grignard reagent. Very much important. Once again I am repeating. So whenever we are treating the grignard reagents with the carbonyl compounds, this falling under the category of nucleophilic addition reaction. Because you could only see that the nucleophile is your alkyl group which is attacking our carbonyl group. But one of the major important things you should also remember, what is that? This reaction is also coming under the concept of preparation of alcohols. Alva? When you are using a formaldehyde or a methanol, you are going to get a primary alcohol. If you are using any other aldehydes, you are going to get a secondary alcohol. If you are going to use a ketones, you are going to get a tertiary alcohol. But do remember the steps is followed by first is the formation of an adduct, then by the acid hydrolysis you will be getting your corresponding alcohols. Is that clear? Very much important. So in today's video we have seen that the two important nucleophilic addition reaction, that is when your carbonyl compounds are treated with alcohols, you are going to get an hemiacetal, acetal in case of your aldehydes, hemiketal and ketal in the case of your ketones, depending upon what is the ratio of alcohols you have taken. Okay. Similarly, when you are talking about the grignard reagents, we came to know that from the carbonyl compounds, of course, we are going to get alcohols, but what type of a carbonyl compounds you are taking depends what type of alcohol you are going to get. If you are using a formaldehyde, you are getting a primary alcohol. If you are using any other aldehydes except that of your methanol, you are going to get a secondary alcohol. If you are using the ketones, you are going to get a tertiary alcohol. Is that clear? So in my next video, we are going to just see the extended part of this nucleophilic addition reaction, and very much important because there we are going to see the ammonia derivatives. Ammonia and ammonia derivatives. In that video, you'll come to know what do you mean by ammonia derivatives. Don't worry of that by hearing the name, but you have to just remember it is also falling under the category of nucleophilic addition reaction itself. I repeat, nucleophilic addition reaction of ammonia and its derivatives, which would be seen in our next video.